Hey everyone, I am Álvaro Ramos. I am a professor at Universidade Federal do Rio Grande do Sul. It's in Porto Alegre, the southernmost state capital in Brazil. And today I'm going to talk about totally umbilic surfaces and hyperbolic trimanifolds of finite volume. And this is a joint work with Bill Meeks and Colin Adams. So first of all, let me explain the main result of the talk. We are working in this ambient space, which is a hyperbolic trimanifold of finite volume. And first, previous works by Colin, Hauswirth, and Rosenberg, and of Meeks and myself, we proved that there are some topological restrictions for constant mean curvature surfaces which are properly immersed in these ambient spaces. Specifically, if sigma is a properly immersed surface in N with constant mean curvature in this range between 0 and 1, so it could be a minimal surface, it could also be a constant mean curvature surface until h equals 1, then it necessarily has negative Euler characteristic. So there are no spheres, there are no planes, there are no projective planes, there are no tori in these spaces properly immersed with constant mean curvature in this range between 0 and 1. Also, if h is bigger or equal to 1, then there are no non-compact h surface in this ambient space with finite topology which are properly embedded. If you ask for immersed, then you can find it, but embedded you cannot find it. So the main theorem I will present in my talk, it's an existence theorem. So it states like this: given h in 0, 1 and a surface of finite topology with negative Euler characteristic, in other words, given something that can happen, that can exist, then it exists. Then there exists a complete hyperbolic trimanifold of finite volume N together with a complete proper embedding of this surface S in N with constant mean curvature H. And if you recall the title of my talk, actually this surface is totally umbilic. Okay, let me give you a few spoilers of the proof just to see if I can convince you to watch the whole talk. Is gonna be really great, I guess. So you fix your admissible topology and your value of h in 0, 1. It could be 0, 2, but think h positive, which is a little harder. So we construct an explicit example of a hyperbolic trimanifold with a totally geodesic surface, sigma, in it, which is diffeomorphic to S. And this example is going to have all the properties you want, like properly embedded, etc. And then after this one example, we start constructing totally umbilic surfaces going parallel to it. But you can only go parallel and remain embedded for small values of the mean curvature. So you need more to reach your value h, which you fixed beforehand. So we use properties of the fundamental group of hyperbolic trimanifolds of finite volume to create a finite covering space of this explicit example, where you can go higher, you can go after values of h that you could before, and you can actually reach h and get these parallel surfaces to the original surface, which are properly embedded and totally umbilic with that value of h. So that's basically the spoiler of the proof. And the tools we use, there are two tools developed previously, which are moves preserving hyperbolicity of link complements, specifically the chain move and the switch move. I will say a few words about them in my talk. And also we use something that I find it really amusing. The name is lerfness. It's a property of fundamental groups of hyperbolic trimanifolds of finite volume. And some advertisement, some related results. This is the bigger picture. I'm not going over the whole statement of this result, but this can be found in our paper too. Okay, so that's it. I hope you enjoy the Geometric Analysis Festival and you enjoy my talk. Thank you very much.